Okay, so for today's lecture we'll be covering conic sections. So there are 5 figures that are formed when a cutting plane cuts a cone or intersects with a cone. A triangle straight down the vertical plane. A circle is a cutting plane that runs horizontal. A ellipse, a parabola, and a hyperbola. So the triangle is straight down the vertical plane. A circle is straight across on a horizontal plane. A ellipse is across the 2 slanted sides of the cone. A parabola is along the starting at one side of the slanted cone and intersecting the base. It has to be parallel to the slanted side of the cone. And a hyperbola is starting at the slanted side of the cone going to the base, but it is not parallel to the slanted side of the cone. That is the difference between a parabola and a hyperbola. A parabola is parallel to the slanted side, while a hyperbola is not. So we did triangles and circles already, so we're focusing on ellipses, parabolas, and hyperbola. A ellipse is the focus of a point that moves so that its distance from a fixed point focus has a constant ratio, always less than 1 to its perpendicular distance from a straight line, directrix. An ellipse has 2 foci and 2 directrices. So this is the construction that you all would be doing in CAD. So you would have a cone here. You could see the phantom edges of the cone and then the truncated side XX. So you divide this cone into, so in the plan view you see the circle, it divided into 12 equal parts. When you project these lines up to the cone and then you pull them up to the top of the apex of the cone, you'll get the cutting plane intersecting with the cone here. So you could draw these lines across the end view, you could draw them down as well. So if you draw them down, you have to pull these lines where the cutting plane intersects the slanted side here. When you go down, you draw them to the center line and then you draw circles. So where this, say on the top, the closest one, where it goes down to the center line, you draw a circle here, and where it intersects with the same projection line, you'll have this intersection point. So the second with the second, then the third with the third. But you have to pull all these across to get the radius that you draw in the circle for them to intersect. So you get 1, 2, 3, 4, 5, 6 points. So each of these 6, you get 6 below and then 6 on top. So you have, say X is exactly, when you pull it down, you get a circle going like that on the intersection points. After you find all the points, you could always project it up to this. So you go straight across and then from these same exact points, you're just matching them up to find the curve. If you're using eccentricity, it's just the distance from the directrix with relation to the distance to the focus. So on one side you have 3 parts, on the other side you have 4 parts. So our distance is the ratio of 3/4. So you have 3 parts here to 4 parts here. So every time 4 over 3 by 10, you have 4 times 10 divided by 3, which will give you this distance here from the directives. And then the 3 parts, or the 10, would be for the radius. So every time you draw all the different radiuses and then you work out the distance from the direction where they intersect. So you get points along the ellipse. So you could do it in a number of ways, given the eccentricity, major and minor axes within a rectangle, and when given the cutting plane in an orthographic view. A parabola is the locus of a point that moves so that the distance from the focus has a constant ratio to the perpendicular distance from the directrix. So basically, if you have 10 here, you have 10 here. So the ratio remains the same. So if you go 15, distance 15. Distance 20, 20. So it's a 1-to-1 ratio. No matter what distance you pick, it will be the same distance from the directive and the same distance to the focus along that point. In orthographic views, this is third angle projection. So the front elevation below, the plan on top. So you have your cutting plane. As I said, you pull it across the slanted side. So say 6 goes across the slanted side, then it goes up to the center line, and then you're drawing that circle. Where the line 6 goes up, intersects with the circle, you get that point. Same thing with 5. Go across to the slanted, up to the center, then a circle. Where it intersect with the 5 line going up, you have the points. The same thing, you keep plotting them until you get a hyperbola. Sorry, parabola. And then, once you have this true curve here, sorry, not true curve, when you have the curve on the plan view, you could always project it back down